Hey guys, it's Jason Digos here with Modus. And on today's workshop, we're going to talk about Modus patented technology called Preact and how we can achieve 500% efficiency. How's that even possible? Well, we're going to get into that right now. So earlier this year, we launched our line of Modus Mezzo amplifiers featuring this Preact current averaging technology. But in order to understand how our technology works, it's first important to understand how a traditional legacy amplifier works. So let's break that down. So let's explain how traditional amplifiers work. What is an amplifier? What is its job? Well, it's really quite simple. An amplifier's job is to take a small audio signal and make that bigger. It shouldn't change the signal at all or alter it or anything. If it does change it or alter it, that's what we call distortion. But an amplifier's job is pretty simple. It's taking a small signal and then making it bigger. So in a traditional, what we'll call legacy amplifier, there are two main components in the amp. There's the power supply side and then the audio amplifier side. So this is the way that things have been done forever, right? You take voltage in from the vehicle and then audio signal in, and then that power supply increases that voltage, feeds it to the audio amplifier. The audio amplifier takes that voltage and current and it makes the audio signal bigger, right? So we need these in car audio applications and marine applications because we need to overcome things like road noise and we want more power and more bass, right? So the downside to this is it potentially could draw a lot of current. It needs multiple amplifiers to develop any type of power. And with all that current and power requirements, it requires big, heavy gauge wire, right? So I think we can kind of all agree on that, on how a traditional legacy amplifier works. So step two, here's a little bit of how to calculate current draw, and it's really simple. We'll do some simple math. So let's just say we've got a regular audio amplifier that is about 1200 watts RMS, and it's operating at 12 volts. Well, that amplifier will probably draw around 100 amps of current. And as we increase that voltage, because as we know, as voltage increases, then current draw decreases. So when we start the engine in that car, we're going to be operating at 14.4 volts. So that 1200 watt amplifier now will draw about 83 amps of current. And then exponentially as we increase the voltage, so let's say an application is 24 volts, then that same amplifier will draw 50 amps of current. So pretty simple math, and this is just how traditional legacy amplifiers work. Now for an explanation on how Modus Preact technology works, let's take a look at this video.
A revolutionary breakthrough, achieving 500% efficiency without the need for specialized wiring. Maximizing power, stability, and seamless compatibility with OEM standards. Our system features a reservoir designed to store power for later use. It functions as a dynamic current optimizer, aligning power flow with the music's demands. During high-energy spikes in the music, the system draws additional power from the reservoir. As this power is used, the reservoir is continuously replenished by a steady flow from the source. When energy demand drops below average, the reservoir recharges, ensuring consistent and reliable performance. Imagine a water tank constantly replenished by a steady stream from a small hose. On the other side, a large pipe occasionally draws massive amounts of water in unpredictable bursts. Despite the sudden demands, the tank remains functional, maintaining its reserve through the continuous flow of incoming water. This is how our reservoir operates, ensuring a steady supply of power, ready to meet high-energy spikes while consistently recharging for seamless performance. All of this is orchestrated by a central brain, the microprocessor. This intelligent system manages the reservoir, source voltage, clipping, and amplifier heat with precision. Unlike traditional amplifiers, it continuously adapts to incoming information, ensuring optimal performance in real time. Say goodbye to clipping, overheating, and unpredictable behavior. This technology sets a new benchmark for reliability and adaptability.
So as you can see from the video, this PREACT technology utilizes a lithium-ion reservoir that stores energy that's coming from the vehicle. So now the vehicle input power supply is totally separate from the amplifier power supply. So that gives us another huge advantage. Our input power supply can accept voltages from 9 volts all the way up to 58 volts, which really widens our application platform. Now that input power supply, controlled by the microprocessor, charges the lithium-ion power bank. Now we talked about that voltage efficiency before, like when we go from 12 volts to 24 volts, we draw less current. Well, our amplifier side now power supply is operating at a 24 volt voltage range. So that lithium ion power bank supplies 24 volts to the amplifier side, making it more efficient. And then now the audio amplifier is drawing current from that internal power supply. So that means that our 1300 watt amplifier can draw just about 20 amps of current, which is 5 times less than a traditional legacy amplifier. And that's how we achieve such high efficiency numbers. We're taking in less current, but we're still delivering very high outputs power. So in this next video, this is a demo that was set up by our engineers, Tony DeMore and Juan Rodriguez, and they're comparing the Modus PREACT technology amplifier and a competitor legacy amplifier set up on the same speakers playing the same source, but just looking at how much current draw the legacy amplifier is versus the Modus amplifier. So take a look. So you've seen that PREACT technology in action. The legacy amplifier was drawing musical peaks and the current meter was peaking at about 80 amps of current draw. Now on the same power supply, same source material, same speakers, the Modus amplifier didn't draw any more than 20 amps of current, which is about 4 times less in that particular application. Now that thing is really cool because it can deliver an extraordinary amount of power, as you've seen, while drawing a very minimal amount of current. So where would you apply this technology? What's it used for? Well, in today's modern cars, electrical systems are very limited because cars today are built for fuel efficiency. Well, we still want to have really nice audio systems that have a lot of output. So Modus PREACT technology is the perfect application for that. In modern vehicles and also in newer vehicles or even EVs, which have a very wide range of operating voltage. For example, we have a demo truck that is a Tesla Cybertruck that operates at 48 volts. And we've got a 6,000 watt system in there that is operating on that 48 volt platform without any issues. And we draw less than 20 amps of current for the whole system. So there are a lot of really modern applications for this in both the automotive and the marine environment. Thanks for joining us in this workshop today. We hope that you learned a lot about Modus PREACT technology. For more information about that technology, our ActEQ patented technology, and all of our products, be sure to visit us at modusglobal.com. I'm Jason Digos, and we'll see you on the next one.